Welcome back to Low Stress Math with Mrs. Bono. We are finally on a new chapter, Chapter 3, Equations. Wouldn't it be more efficient to just find out who's complicating equations and ask them to stop? Probably, but we're not going to do that. We're going to learn how to solve equations. And if you look up here at this equation, it looks really complicated, but in fact, it's not that bad. And you're going to be able to solve equations like that without trying to skip anything. So please put your name and your period number on the bottom of the first page, and let's get ready to start. Lesson number 1, Introduction to Equations. What makes an equation? Well, you know I love to start with vocabulary so that we're all speaking mathematically. And an equation is a mathematical sentence stating that two quantities are equal. So you've been using equations forever. When you were in first grade and they said 1 plus 3 equals 4, that was an equation. And in the first chapter, we dealt with expressions and simplifying expressions. And you couldn't really solve most of those because there was no equal sign. Mostly we just made them easier to deal with. So an expression represents a value by combining numbers and or variables using mathematical operations. Multiplication, division, those are what makes something a term. Remember we talked about terms? Terms can have a multiplication or division, but they can't have addition or subtraction. So this is a term. 5 is a term. 20 is a term. But this has something going on here. This term is a numerical variable or product of numbers and variables. Expressions, what's the difference between a term and an expression? An expression is when you add or subtract terms. And a term is the product of numbers. So most terms have a coefficient, and that's that number 3 there. And a variable, and that right there is my variable x. Now sometimes they have sometimes your variable or your coefficient is going to have an exponent. We're not going to do a lot of exponents in this chapter, but we will do a few. All right. So that's addition or subtraction. What's addition or subtraction? Well, that is a mathematical operation. So there's a lot of mathematical operations, so Bono, man. Yeah, that's going to be addition. And this number here, that's a type of number we haven't dealt with very much, but that plus 5 is a constant. Now, I'm sure you've heard something like E equals mc squared, and the c stands for constant. And in that particular equation, the constant is the speed of light. But constant is just a number that stays the same. Thus the word constant. It's constantly the same. A variable can change. And a coefficient is what you multiply times a variable. All right. And I spelled addition wrong, and you were going to let me get away with that. Oh, Bono, 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 Bono. What on earth? I can't believe I did that. I have to find my whiteout. Oh my goodness, what am I going to do? All right, I found it. I feel better now. So, next. Solving equations. All right. To solve an equation, use the inverse to undo what has been done in order to get the variable by itself. So the whole goal of solving equations is to do what's called isolate the variable. And if you've ever heard of isolation, that's where somebody is put by themselves. You isolate somebody, you put them alone. When you isolate a variable, it's all by itself. It doesn't have any addition or subtraction or multiplication or division with it. It's all alone on one side of the equal sign. And on the other side is where all the numbers are going to end up. So to get the variable by itself, I'm going to write the word isolate underneath here. Isolate the variable. All right. So to solve equations, use the inverse operation. A lot of I words today. To undo what has been done in order to get the variable by itself, in order to isolate the variable. So if the operation is addition, the inverse, what undoes addition? Subtraction. And the inverse of multiplication, division. Now, if you look here, you can see I have arrows going in both directions. That means that the inverse of subtraction is addition, and the inverse of addition is subtraction. It goes both ways. The inverse of multiplication is division. The inverse of division is multiplication. Remember, the goal in solving equations is to get the variable by itself. I'm going to write isolate the variable because I like to sound like I know what I'm talking about. And I'm actually going to grab my highlighter right now, and I'm going to highlight up here where it says get the variable by itself, because that's how you're probably going to think of it. But when you speak, you always want to sound like you're educated. So isolate the variable is what you would say. All right, these are one-step equations, relatively simple. So I am going to do examples 1, 2, 3, and 4, and you try the other examples. Because you know, the only way to learn math is to do math. So the steps to solving a problem: rewrite the problem, show the inverse, and the last step is the variable equals the solution. So I'm going to rewrite my problem. But it's right there. No, I don't care. B minus 9 equals negative 8. And it's always the inverse of what's by the variable. I want to get the variable by itself. So in order to isolate that variable, I have to get rid of this 9. And the inverse of minus 9 is plus 9. And if you do it to one side of the equal sign, you have to do it to the other. So I'm going to add 9 to both sides. B plus 9 minus 9. This becomes 0. I want that to disappear because I want the B alone. Negative 8 plus 9, well, negative 8 plus 9 is 1. So there's my solution, 1. Example 2. Rewrite the problem. 12 plus y equals negative 3. Now the opposite of adding 12 is subtracting 12. So the inverse is subtract 12. So you're going to subtract 12 from both sides. Now 12 minus 12, again, the goal is to make this disappear so the y is alone, because 12 minus 12 is 0, equals negative 3 minus 12. Negative 3 minus 12. Oh, I might need a calculator for that. Nah, I know it's negative 15. So there's my answer. Oh, what is this? Well, let's rewrite it. First of all, I'm going to make that negative 5 very large. Negative 5v equals 24. Now, the inverse of multiplying by a number is dividing by a number. And in algebra, you write division like a fraction. So I'm going to write this as divide by -5. Divide by -5. -5 divided by -5 is 1. So I get V, and then I have to do 24 divided by -5. Some people would leave that as a fraction, but I kind of want the decimal, actually. So it doesn't really matter if you leave it as a fraction or write it as a decimal. It's up to you, but my preference is decimals, so it is -4 8/10. Positive divided by a negative is -4 8/10. All right, this, I'm going to write this very specifically. -7 equals h divided by 3. And the inverse of division is multiplication. And honestly, it's much easier to show multiplication with parentheses. So from now on, that's just what we're going to do. We're going to show multiplication in parentheses. So times 3 on both sides. Now let's see, to get the h by itself, 3 divided by 3 is 1. Now that h is alone, just the way it wants to be, equals 7 times 3 is 21, but -7 times 3 is -21. And that kind of looks like subtraction. That's why I put parentheses around the 3. And if you want, you could even put parentheses around the 7. That way it really looks like multiplication because it's 2 parentheses. So now stop the video, take a deep breath, relax, and try the problems. They're very much like the examples we did. Okay, I'm hoping that you tried the problems, because you know, I'm going to say it again, I always say it, the only way to learn math is to do math. So we're going to isolate some variables here. You know what? I'm just going to put the directions down up here over something. 1, rewrite the problem. 2, inverse on both sides. 3, solve it. Now look at that, I'm spelling things wrong again, but now I have my white out, so I feel much better. I didn't spell the whole thing wrong. Kind of looks like save it, but no. Solve it. And now I'm going to put big puffy cloud of thought around there, because that's what I'm thinking when I'm doing my problems. I'm going to rewrite the problem. I'm going to put the inverse on both sides. Then I'm going to solve it. So, rewrite the problem. K minus 17 equals 3. The inverse of subtraction is addition. So I'm going to add 17 to both sides. And let's see. Negative 17 and positive 17, or minus 17 plus 17 is 0. Bring down the k equals 3 plus 17 is 20. Boop, boop, boop. Frame it because it's beautiful. Rewrite the problem. X plus 13 equals 9. The inverse of plus 13 minus 13, and minus 13 on both sides. And look at that. 13 minus 13 is 0. Bring down the x. 9 minus 13, the signs are different, so you subtract. 13 minus 9 is 4. 13 is bigger than 9, so it's negative 4. Or use a calculator, because I know you're lazy. Here we go. Negative 8m equals negative 24. Okay. The inverse of multiply by negative 8 is to divide by negative 8. Don't lose your signs either. You got to be careful about that. -8 divided by -8 is 1. The m comes down by itself. And the signs are the same, negative, negative. So when the signs are the same, the answer is positive. And we'll put a little frame around that because it's pretty. Oh, I forgot to frame you. Darn it. There we go. Last problem. You know, it's an equal sign, and I don't like having the P on that. I'm going to flip it over. I'm going to write it like this. P divided by 2 equals 15. Can I do that? Yeah, it's an equal sign. Both sides have to be equal. They have to be the same. So, the inverse of divide by 2 is to multiply by 2. So I'm going to multiply both sides by 2. And 2 divided by 2 is 1. P equals 15 times 2 is 30. Frame it, it's beautiful. Okay, let's take a look on the next page. Ugh, lesson 2. No, I don't want to do lesson 2. All right, good luck. I will talk to you soon. Bye.